Do you remember when we were talking about relationships and we said that we can have straight line relationships or non-straight line relationships? And yeah, we're going to concentrate specifically on straight line relationships for the rest of this entire unit. What is a straight line relationship? It's called a linear relationship. Why? Well, linear relationships are straight lines, and they're going to be, remember, a straight line was something called constant. Yes, it's constant. Whereas a non-linear relationship, anything that forms like a curve or something, look at this, was not linear. Remember, that was kind of like the growth curve, which called a J curve. Go back a couple of podcasts and watch it. Okay, so here we go. How does this work? Nonlinear and linear relationships. There's a number of ways of determining whether a relationship is linear or a nonlinear. Linear, again, straight lines. That's the most important part. So anything that looks like this is considered to be linear. Nonlinear, look at that. All kinds of crazy curves. As soon as you throw a curve in there, it's no longer a line. Because even when you look at the word linear, the word line comes through. That's a great way to remember it. So if you were given something like a table of values, how can you tell if this table of values is linear or nonlinear? Well, again, remember what I said earlier. It has to be a constant. Look at this relationship. You're going from 2 to 3 to 4 to 5. You're always going up by ones. The difference between them is always 1. Now look at the relationship on the y-axis. 8 to 11 is increasing by 3. 11 to 14 increases by 3. 14 to 17 increases by 3. That's a constant, right? That's a constant. And so guess what? That is linear. Cool, right? Now, don't be fooled, because look, even though this is going up 2, 3, 4, 5, it looks like they're going up at one at a time. Check this out. This goes from 8 to 27, which is a difference of 19, whereas this means going from here to here, look at this. It's a difference of 37. From going to here, it's a difference of 61. These are not constant, so guess what? Not linear. Also, the next way you can tell, okay? So you can tell this graphically. This is a graph, which is a straight line. You can tell it by a set of values, okay, which is constant, 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 right? But here's the last way to determine it. Linear relationships always have a degree of 1, okay? They always have a degree of 1. So what do I mean by this? Look, that's to the exponent of 1. That's to the exponent of 1. That's to the exponent of 1. Every one of these will be some kind of line relationship. Look at this. This is an exponent of 2. That's not a line. This is an exponent of 3. That's not a line. What the heck is this? Well, you'd have to divide it by x and divide it by x and realize that's x to the negative 1. And again, that is not linear. So I think the most important point when you're looking at an equation, you got to look for the degree. It has to be 1. It can't be 2. It can't be negative 1. It can't be 3. It has to be a degree of 1. So, okay. So let's sum up. All right. What is a linear relationship? It's a constant change in the independent variable results in a constant change in the dependent variable. So in other words, a constant change in the x gives you a constant change in a y. That's why the graph of a linear relationship is a line. Yay! Okay, the degree is always degree of 1. So your x or your y or whatever is always going to be 1. So something like y equals to 3x plus 5. There's the degree of 1. That's the degree of 1. That's linear. And then the change in both variables is constant. Sure, the y can go up by, let's say, 10s, and the x can go up by 1s, but is every y going up by 10? Sure, then it's linear. If every y is going up by 10 and every X is going up by a constant amount, constant X, constant Y, it's going to be linear. All right, so let's look at some examples. Here we go. Which table of values represents a linear? Okay, so here we go. We got a relationship between the number of bacteria in a culture and time. So, okay, look at this. Look how these times are going up by 10. Oh, sorry, by 20. Oops. 20 goes to 40. That's going up by 20. 40 goes to 60. That looks so far, it looks so far like we're going up by a constant amount, right? Okay, let's look at this. That goes up by 1. Uh-oh. That goes up by 2. That went up by 4. That went up by 8. No, not linear. Look at this one. Relationship between goods and services tax. Okay, I got 60 going to 120. That's increasing by 60. 120 going to 180. That's increasing by 60. So again, so far so good. We're doing pretty good. Here we go. Let's look. 3 to 6, that's going up by 3. 6 to 9, that's going up by 3. 9 to 12, going up by 3. 12 to 15, going up by 3. There's your linear relationship, and that's how that works.